Hello students, welcome to EPG Pathshala. I am Dr. Sushma Talegaonkar from Jamia Hamdard. Today we are going to talk on the module Preparation of Liposomes from paper Novel Drug Delivery System 2. Learning objectives of today's lecture are: first, we will discuss classification of methods of liposome preparation. Second, passive loading techniques, under which we will discuss lipid film hydration method, solvent dispersion method and detergent removal method. Then size reduction of large multilamellar liposomes, which we generally obtain from passive loading technique, that we will discuss. And last, actual loading technique for the preparation of liposomes. There are number of methods available for preparation of liposomes. Drugs can be loaded into the liposomes either passively or actively. Based on this, methods for preparation of liposomes are broadly classified into two. First, passive loading methods, and second, active loading methods. Methods of preparation of liposome. They are divided into two: passive loading technique and active loading technique. Passive loading technique comprises of first lipid film hydration, solvent dispersion technique, which is again divided into ether injection, ethanol injection, double emulsification, reverse phase evaporation. Third method under passive loading is detergent removal method, which is again containing dialysis, detergent adsorption and chromatography. The liposomes which we are getting from passive loading, they are mostly larger in the size. So after preparation, we generally reduce their size by using sonication, French pressure cell extrusion and by membrane extrusion method. Now students, we have already seen the detailed classification of method of preparation of liposome. Now let us start with passive loading technique. In passive loading methods, drugs are added during the formation of the vesicles itself. Hence, loading the drugs into the liposomes passively. Passive loading methods include following three approaches. First, lipid hydration method, solvent dispersion method and detergent removal method. Let us start with the first approach, that is lipid film hydration method. Lipid film hydration technique is the most commonly used method for preparation of liposomes. It involves following three basic steps. First, preparation of dry film of lipid. Second, hydration of lipid film in aqueous media. Then the third is size reduction of the prepared large unilamellar or multilamellar liposomes. In the first step, the lipid is dissolved in suitable organic solvent to prepare a lipid solution. The organic solvent used is usually ether, chloroform or a mixture of chloroform and methanol. The solvent is then removed by evaporation of the solvent by using rotary evaporator. This results in the formation of very thin layer of lipid on the sides of round bottom flask. Next, the hydration of lipid film is done. It is achieved by adding an aqueous solvent into the round bottom flask and agitating it in such a way that the aqueous media constantly move over the lipid film. Addition of the aqueous phase causes the lipid molecules to arrange themselves in the form of bilayer. After hydration, vesicles are formed due to swelling of lipid bilayer. These vesicles are large and multilamellar, which are then treated further to reduce their size either by sonication or by film or the membrane extrusion method. This diagram is showing the preparation of liposomes by film hydration method. The first step is the preparation of the lipid solution in round bottom flask. Then after getting a clear lipid solution, this flask is going to be attached with the rotary evaporator. Then after putting this flask in rotary evaporator, the organic solvent is going to be evaporated and a thin film of the lipid is going to be formed at the side wall of the flask. Then remaining organic solvent we are going to remove by vacuum under the nitrogen. This will lead to the formation of dried lipid thin film inside the round bottom flask. Then complete drying occurs. Then we do the hydration of this lipid film with the water or phosphate buffer, and slow hydration of this lipid film will lead to the formation of liposomal dispersion. Then this dispersion we generally store in nitrogen environment in order to prevent the oxidation of this lipid material. So liposomes, they are generally stored at 4-degree temperature. Now let us see what are the advantages of this method. This is the simplest method for preparation of liposomes. This method does not involve any expensive and complicated equipment. It does not require maintenance of high pressure or temperature. Disadvantages of this method, they are: first, liposomes formed are usually large unilamellar liposome or multilamellar liposomes. Encapsulation efficiency is low and liposomal population is heterogeneous in size. Now, there are the various process variables which affect the efficiency of this method. So, let us see what are the process variables which are very important during the preparation of liposomes by this method. First, main step in this method is the formation of lipid film. If the film is not thin and uniform, then the liposomes will be either be very large and having several lamella or will not form at all. Thick and non-uniform lipid film will result into lumps and aggregated masses of lipids. During the evaporation of the organic solvent, the rotation of the vessel or round bottom flask must be consistent and continuous. So, it will lead to the formation of very thin and uniform lipid film. Modifications of lipid film hydration method. Lipid film hydration method is modified to improve the encapsulation efficiency of the vesicles. There are two common modifications of this method as explained below. First is dried reconstituted vesicles. As the name of the technique suggests, the liposomes are first freeze dried and are then reconstituted by adding aqueous phase. The hydrophilic materials that are to be encapsulated are added to the dispersion of small unilamellar vesicles, and then the mixture is freeze dried. In the next step, the freeze-dried membrane is subjected to rehydration by dispersing the film stacks in an aqueous phase. This results in formation of uni or oligolamellar vesicles entrapping the hydrophilic material in their core. Another modification of lipid film hydration method is freeze-thawed liposomes. Freeze-thawing of liposomes is mainly done to increase their encapsulation efficiency. In this procedure, the aqueous dispersion of small unilamellar liposomes is first freeze-dried with the solutes to be entrapped, and then the mass is slowly thawed. Thawing means to make a frozen mass soft by warming it up. The repeated cycles of freezing and thawing increases the space between the consecutive bilayers. Next, the mass is subjected to sonication for 15 to 30 seconds. The short cycles of sonication causes the dispersion of aggregated material into large unilamellar vesicles. The large unilamellar vesicles are formed due to the fusion of the small unilamellar vesicles during the entire process of freezing and thawing. This diagram is showing both modification, that is freeze-thaw sonication and dried reconstituted vesicle modification. The diagram is showing first small unilamellar vesicle in aqueous phase, then the small unilamellar vesicles we are generally exposed to the solutes which has to be entrapped. Then after that we generally go for freeze drying. After freeze drying, a dry film we are getting in the round bottom flask. Now there are the two techniques. This freeze dried membrane Again, we generally do the rehydration and we generally get the uni or oligolamelllar vesicles. While when this freeze-dried membrane is going for thawing and then sonication, then this will lead to the solutes in unilamellar vesicles. Solvent dispersion technique of formulation of liposomes. First step is same as that of lipid film hydration technique, that is to prepare an organic solution of lipids. Next step, the lipid solution is added to an excess of aqueous phase which contains the hydrophilic material which are to be encapsulated in the liposomes. This results in the alignment of the lipid molecules at the interface of the organic and aqueous phase and form a single layer. This monolayer of the phospholipids contributes to the formation of the bilayer of liposomes. Solvent dispersion method is again divided into three. First, ether injection method, ethanol injection and reverse phase evaporation. First, we are going to discuss ether injection method. The lipids are dissolved in diethyl ether or mixture of ether and methanol. This lipid solution is injected into an aqueous solution containing the drug to be encapsulated. The addition is done at an extremely low rate, that is around 0.25 ml per minute. The addition is performed at reduced pressure and at a temperature above the boiling point of ether, that is 55 degrees centigrade to 65 degrees centigrade. Ether is then removed under vacuum, which leads to formation of liposomes. Advantages of this method. Ether injection method does not cause oxidative degradation of lipids. Disadvantages of this method are heterogeneity of liposomal population produced, size ranges between 70 to 200 nanometer. Another disadvantage is exposure of compounds to be encapsulated to organic solvents at high temperature. Process variables which affect the efficiency of this method, and one should be very cautious regarding these process variables. First, process variable, the characteristic of the final liposome mainly depend upon the rate of addition of ether solution into an aqueous phase. A faster rate of addition will result into larger vesicles. Other variables are the temperature and the pressure at which the addition of the ether solution is done. Another method for the preparation of liposome is ethanol injection method. In this method, first lipids are dissolved in ethanol to make a homogeneous solution of lipids. This ethanol solution of lipid is injected at a faster rate into a huge amount of aqueous media or buffer solution under continuous stirring, which contains the compounds that are to be encapsulated. As a result of the interaction of lipids in solution with the aqueous environment, the multilamellar liposomes are formed. Advantages of this ethanol injection method is, first, ethanol injection method is very simple and convenient. The sensitive lipids are at a very low risk of degradation. Disadvantages. Population of the liposomes is heterogeneous, size ranges between 30 and 110 nanometer. Dispersion of liposome is very dilute as huge excesses of aqueous media is used. Another disadvantage of this method is complete removal of ethanol is very difficult because ethanol has a tendency to form an azeotropic mixture with water. Next, there is a high probability of inactivation of the various biologically active macromolecules in presence of even low amount of the ethanol. Process variables. The process variables of this method include the stirring rate of the mixture while addition. A continuous stirring at a sufficiently high speed is essential for producing smaller vesicles. The diagram is showing ethanol injection method and ether injection method that we already discussed, and this is a diagrammatic representation of these two methods. And we generally we can see in this diagram a small unilamellar vesicles are obtained by ethanol injection method, while large unilamellar vesicles are formed in case of ether injection method. Double emulsification technique. Liposomes are prepared from a double emulsion technique. In water in oil in water, double emulsion, or water in organic solvent in water, double emulsion, microdroplets of water are contained in the droplets of lipid which are suspended in aqueous phase. The two water media are separated by a bilayer of lipid whose hydrophobic surfaces face each other across a thin layer of organic solvent. If the organic solvent is removed, lipids will form a rigid bilayer resulting in the formation of liposomes. Double emulsion is prepared by injecting the suspension of microdroplets into hot aqueous solution under vigorous stirring. Organic solvent is evaporated by strong jet of nitrogen. Volume is adjusted and product is centrifuged at 20 degrees centigrade for 30 minutes at 37,000 frequency to remove lipid aggregates. Advantages of these methods are unilamellar vesicles of intermediate size are formed. Theoretical entrapment yield is 100%. Reverse phase evaporation technique. Organic phase containing dissolved lipids and aqueous phase are mixed together by sonication to form water in oil emulsion. This leads to the formation of inverted micelles. The organic solvent is then removed under reduced pressure, which results into conversion of inverted micelles into viscous gel state. Next, residual solvent is removed through continued rotary evaporation under reduced pressure. At that point, the excesses of phospholipids form the second half of the bilayer and thus liposomes are formed. This diagram is showing the preparation of liposomes by reverse phase emulsification method. Advantages of reverse phase evaporation method. Encapsulation efficiency is as high as 65%. This method can be used to prepare liposomes from a number of lipids. Second advantage is reverse phase evaporation method has also been used to encapsulate molecules of a very wide range of size. Disadvantages of this method. Materials to be encapsulated are made to come in contact with the organic solvents and sonication cycles. Students, let us discuss another method of preparation of liposome, that is detergent removal method. This method is also a passive loading technique. In this method, the detergents are first used to solubilize the molecules of phospholipids in an aqueous phase and then are removed to form liposome suspension. When detergents are added to an aqueous solvent at a concentration above their critical micelle concentration, that is called the CMC value, along with the lipids, the detergents and the lipids form mixed micelles, where the hydrophilic part of the detergent molecules face towards aqueous phase and their hydrophobic part covers the lipid molecules, thus shielding lipid molecules from aqueous solvent. Next step is to remove the detergent. When the detergent leaves the solution, the micelles progressively become devoid of detergent molecules. Finally, the micelles, which are now made up of entirely of the phospholipids, combine together to form a large unilamellar vesicles. The detergents are removed by any of the following methods. First, by dialysis, second, by detergent adsorption, and third, by gel-permeation chromatography. Dialysis. The detergents can be easily removed through the dialysis. LipoPrep is a dialysis system which is available commercially and can be used to remove detergents. The dialysis is performed in the dialysis bags which are engrossed in large detergent-free buffers. This is called equilibrium dialysis. Advantages of this method: the dialysis method of removing detergents offers good reproducibility. Second, liposome populations are homogeneous in size. Disadvantages of this method: the main limitation of this method is the inefficient removal of detergents, which may lead to retention of their traces in the liposomes. Detergent adsorption. This is a technique by which we can remove the detergent which we have used for the preparation of liposome. In this method, the detergents are removed by adsorbing them onto other detergents such as Triton X100, Colage and alkyl glycoside. This is achieved by mixing and shaking solution of mixed micelles with beaded organic polystyrene adsorbers such as XAD2 beads and BioBeads SM2. Advantages of this detergent adsorption method. The advantage of detergent adsorption method is the elimination of detergents even with a very low critical micelle concentration which are not depleted completely. Disadvantages: additional detergents are required to carry out this process. Gel-permeation chromatography. In this technique, detergent is depleted by size spatial chromatography. The liposomes percolate through the spaces between the beads. Pre-treatment is essential as the swollen polysaccharide beads would adsorb significant quantities of amphiphilic lipids. The pre-treatment can be done by saturating the gel filtration column prior to use with lipids using blank liposome suspensions. Columns that can be used for gel filtration include Sephardex G50, Sephardex G100, Sephardex 2B to 6B and Cefacryl S200 to S1000. The process variables which affect the efficiency of this process, that is, rate of flow, is the important process variable. The segregation of liposomes from detergent monomers is very effective at lower rates of the flow. Size reduction of liposome. As we already discussed, the liposomes which is formed by passive loading technique, they are generally having the large size. Size reduction of the liposome formed by passive loading technique can be accomplished by using any of the following techniques. First is sonication, second French pressure cell extrusion, and third one is membrane extrusion technique. First technique of size reduction is sonication. Sonication is reportedly the most suitable technique to prepare smaller sized unilamellar vesicles. Sonicators work on the principle of energy of ultrasound waves produced by ultrasonic transducers. In sonication method, multilamellar vesicles are sonicated in a sonicator for a suitable period of time. The two types of sonicators are bath sonicator and probe sonicator. First, bath sonicator. Bath sonicator is like a big water bath. Sample which is to be sonicated is kept in the tub of the bath sonicator. The assembly comes with a temperature regulator and thus maintaining the temperature of the sample is easier. The high energy of the sound waves break the large multilamellar vesicles into smaller unilamellar vesicles. Second type of the sonicator is probe sonicator. It is a tube-like structure and is enclosed in a wooden box. Lower tip of sonicator is immersed directly into the dispersion of liposomes. Tip of the sonicator puts a very high amount of energy into the dispersion and thus breaks the larger vesicles into smaller ones. High amount of energy produces heat which might degrade the sample. Thus, it is advisable to keep the sample in an ice bath to prevent its temperature from rising. Advantages of sonication. High frequency sound waves reduce the size of the large vesicles very efficiently and effectively. Disadvantages of sonication. First, the high frequency sound waves might sometimes degrade the lipids. Second, sound waves may induce charge on the lipids, which can result in the aggregation of the vesicles, thereby increasing their size. Third, the tip of the probe sonicator may contaminate the liposome dispersion. Process variables during the sonication methods. The process variable of sonication method mainly include the sonication time. Lesser time may result into inefficient size reduction, and longer sonication cycles may cause aggregation of the vesicles by inducing charge on them and may even degrade the lipids. Thus, an optimum sonication time has to be determined. Another method for size reduction of liposome is French pressure cell extrusion method. In French pressure cell extrusion method of size reduction, the multilamellar vesicles are made to extrude through a very small orifice at a very high pressure of 20,000 psi and temperature at 4 degree centigrade. Advantages of this method is the method is very simple, speed is very high, reproducibility and gentler handling of unstable material. Disadvantages of this method: difficulty in achieving and maintaining temperature. Second, relatively smaller working volumes, maximum 50 ml. Another disadvantage: liposomes are relatively bigger than that produced by sonication. Process variables of this method. The process variables of French pressure cell extrusion method include the size of the orifice and the pressure. The diameter of the orifice decides the size of the final vesicles, while the high pressure is required to push the large vesicles through the orifice at a faster rate. In membrane extrusion method, the multilamellar vesicles are made to pass through a membrane under high pressure of around 250 psi. The membrane is made up of polycarbonate. Since the pore size of the membrane is very small, 0.8 to 1 micron, the layers of multilamellar liposomes get peeled off until only one layered vesicles of small size are left. The advantages of membrane extrusion method are: this method produces the liposomes with reduced size. Liposome population has homogeneous size range as the size of all the pores of the membrane is more or less same. This method is suitable to produce stable liposomes with a variety of lipids. Disadvantages of this method: first, a high pressure is to be attained. Second, this method is not as effective as sonication and produces relatively large vesicles. Now, let us discuss another technique for the preparation of liposome, that is active loading technique. In active loading technique, drugs are loaded into the pre-formed empty liposomes using various approaches such as pH gradient, electric gradient and potential difference across the lipid membrane. In active loading, several drugs such as lipophilic amines are taken up and accumulated in the liposomes which exhibit a membrane potential or pH gradients. Active loading of drugs through pH gradients involves the preparation of liposome in a buffer having low pH and then adjusting the external pH to 7 or higher. Subsequently, the drug is added and the dispersion is incubated for short periods of time. The lipid bilayer is generally impermeable to ionic molecules and larger hydrophilic moieties. Ions can be transported across the lipid bilayer by use of ionophores, whereas that of the neutral and weakly hydrophobic molecules can be regulated by concentration gradient. Empiphatic compounds can be drawn inside the liposome due to a difference in the proton concentration across the liposomal membrane. Advantages of active loading techniques. This technique offers following advantages over passive encapsulation techniques. Encapsulation efficiency and capacity is higher in active loading. Second, leakage of encapsulated drugs is less. Third, active loading gives freedom of using any type of lipid because drug is loaded after the liposome formation. Limitations of active loading technique. The technique is not suitable for hydrophobic drugs. Second, it requires presence of weakly basic functional groups. Third, only a few of therapeutic agents possesses the characteristics which are necessary for active loading with the established techniques. Fourth, this technique also requires certain special conditions such as pH or electrostatic gradient, which will help the drug to cross the lipid membrane. So, students, let us see what we have learned from today's module. First, we came to know that there are several methods for preparation of liposome. These methods are broadly classified as passive loading and active loading techniques. In passive loading methods, the drugs are loaded during the formation of vesicles, while in active loading methods, the drugs are loaded after the formation of liposomes. Passive loading techniques further include several methods. All the methods have few advantages and disadvantages. Choice of suitable methods depends on the desired property of liposome, or we can say for what purpose we are preparing liposomes. For example, long circulation, of a active targeting, of a passive targeting, of a controlled release or sustained release preparation. So according to the need, we can modify the surface of the liposome. We can also go for a particular size of the liposome and some other modification we can do on the surface of liposome.